So next up, section 4.3, we're going to be covering the slopes of lines. The slopes of parallel lines, the slopes of perpendicular lines, the slopes of lines in general. So first we need to determine how to actually calculate the slope of a line given 2 points. So for number 6, I'm given these 2 points, x and y. X is at -1, -1. Y is at 4, -2. Now to determine the slope of the line that passes through these 2 points, you don't necessarily have to plot these 2 points in a coordinate grid. You can definitely do that, and that's definitely a good strategy. But if you don't have graph paper handy, we can still determine what the slope is by having a little slope formula. So recall that my slope formula states that m is equal to y2 minus y1 over x2 minus x1. Okay, and in this formula, m represents the slope of my line. And then y2 and x2, so these two right on top of each other, they represent one of my points. Y1 and x1 represent the other one of my points. So we just take the two y's and subtract them from one another, and we take the two x's and subtract them from one another. And really, it doesn't matter which one you label your x1, y1, and your x2, y2. The only thing that matters is when you are setting up this formula, make sure that the two numbers that create a point together, make sure that they're on top of one another. So in my example here, it's number 6. I've got -2 minus -1. So it's always going to be minus. Even if your numbers are positive or negative, it's always going to be minus. So it's -2 minus -1 over 4 minus -1. So you see right here, the -2 and 4 are right on top of each other because they create a point. The -1 and -1 are right on top of each other because they create a point. Well, now I just need to simplify this. So -2 minus -1, this will be -2 plus 1 to give me -1. And then 4 minus -1 will give me 4 plus 1 to give me 5. So the slope of the line that passes through points x and y is -1/5. So next up on number 8. So in the last example, number 6, we were given 2 points and asked to determine the slope of the line that passes through them. On number 8 instead, they give us a line that has been graphed, but don't tell us any points. And so they still want us to determine what the slope of the line is. Well, if they have a line graph for you, try to see if there's any 2 points that you can clearly mark. Okay, so I picked these 2 points merely because where they are at on the line is a clear spot where there's two of these lines intersecting, an Y line and an X line. So I picked these 2 points. So now recall from Algebra 1 that slope, we could say, is just equal to rise over run. Okay, so even if you don't have your formula handy, if you can remember that slope is equal to rise over run, you take your first point and you see how far up or down do I rise to get level with my other point. So here I go 1, 2, 3, 4. I have to go up 4, so I've got +4 in the top. And then to see how far it gets until I'm right on top of my point, I have to run over either left or right. So I have to run 1, 2, 3. So I ran 3 in the right direction, so in the positive direction. So I'm going to have 4 over 3 for the slope of my line. And so in theory, if this is the slope of my line, I know it's a little bit difficult, but if we were to keep extending it, and we could see that our line would continue as long as we go up 1, 2, 3, 4, and over 1, 2, 3. And so my line could still continue and have new points pop up. All right, so for number 12, we need to determine if line 1 and line 2 are parallel, perpendicular, or neither. So keep in mind, when we're determining if two lines can be parallel, perpendicular, or neither, we're looking at the slopes of the lines. So if two lines have the same slope, then we can determine them to be parallel. If two lines have slopes that are opposite reciprocals, we can determine them to be perpendicular. And if they have neither the same slope nor their slopes are opposite reciprocals, then they will be neither. They're going to intersect in some way, but it won't be in a perpendicular fashion. So let's look at lines 1 and 2. So in order to determine if these two lines can be parallel, perpendicular, or neither, we need to determine what the slope is. So they give us 2 points on each line to help us determine the slope. So for line 1, if I'm starting here, I have to go up 1, 2, 3, and then I have to run 1, 2, 3, 4, 5, 6. So the slope of line 1 is 3 over 6, which I can just reduce down to 1 over 2. So in order for these two lines to be parallel, my other slope would need to be 1 over 2. In order for these two lines to be perpendicular, my slope would need to be negative 2 over 1. Because remember, opposite reciprocals. Opposite tells me the signs have got to be different. So one has to be positive, one has to be negative. And the reciprocal tells me flip the fraction. So 1/2, the opposite reciprocal of it, would be negative 2 over 1. So let's see, line 2. From here, I have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have to run over 1, 2, 3, 4, 5, 6. So the slope of this line is negative 10 over 6, which I can reduce down to negative 5 over 3. So since my slope isn't 1/2, these two lines aren't parallel. Since my slope isn't negative 2, these two lines aren't perpendicular. So because of that, these are going to be neither parallel nor perpendicular. All right, so next up, number 14. Still using the same instructions, determining if two lines are parallel, perpendicular, or neither based on their slopes. So just like with the last one on number 12 that we saw just here, it appeared from first glance that they could be perpendicular, that those two lines intersecting could create right angles. But when we inspected it a little bit further, we saw that their slopes were not opposite reciprocals of one another. They were 1/2 and negative 5 over 3. So therefore, these two lines couldn't be perpendicular. So looks can be deceiving. Let's look at number 14. Okay, so at first glance, these two lines seem like they could be parallel. But let's inspect a little bit further. So line 1. If I'm going to determine the slope of line 1, I'm just going to count from point to point doing my rise over run. So I want to say 1, 2, 3, 4, 5, 6, 7, 8, 9, and run 1, 2. So my slope of line 1 is 9 over 2. And now for line 2. Slope is going up 1, 2, 3, 4, 5, 6, 7, 8, running over 1, 2. So the slope of line 2 is 8 over 2, or simplified down to 4. So since 9 over 2 and 4 aren't equal, they're not parallel. Since 9 over 2 and 4 are not opposite reciprocals, these two lines aren't perpendicular. So they're neither parallel nor perpendicular. These are just going to be intersecting in some form or fashion. Even though they're not intersecting in this picture, if we kept extending the graphs further and further, at some point they would intersect. All right, so number 17. Now we are given 4 points, and we're told that in points F and G, there's a line that goes through them and connects them. And in points H, J, there's a line that goes through these 2 points and connects them. And so we're asked to determine if these two lines are parallel, perpendicular, or neither. So just like with 12 and 14, the way to determine that is using their slopes. So let's determine the slopes of lines FG, named by the 2 points that are on that line, and line HJ. Well, recall that my slope formula said that M equals y2 minus y1 over x2 minus x1. So let's plug those in. So for my line FG, I'm going to have 5 minus, always going to be a minus, negative 3 over 1 minus negative 1. So 5 minus negative 3 will give me 8. 1 minus negative 1 will give me 2. 8 over 2 will reduce to 4. So now let's look at HJ. So y2, 7, minus y1, negative 1, divided by x2, 2, minus x1, 0. 7 minus negative 1 will give me 7 plus 1, which will be 8. Over 2 minus 0 will be 2. 8 over 2 reduces down to 4. So since both of these have a slope of 4, these two lines are parallel to one another.